FX. Panasonic.
Oh yang
Yang lebih lucu lagi tuh Fujitsu. Itu 7 watt doang katanya. Makanya tuh pasang
malam ini kita kembali oh emang first time
sebenarnya diperluin tapi baterai sama terus makanya apa kan? Cepetin belakang ya? Cepetin belakang ya? Magnet pas tapi kurang kuat ya? Kuat aja itu kayak magnet oh magnet pas wah Nah, BOM ngomong ini aja nih nyatu tuh di dalam. Sorry, guys. Susunya setelah apa? Nggak pernah. Everybody, did that?
Itu kan pasti ada yang beda. Ada yang bisa pakai nggak? Mostly sama kan? Ada pun tahun ganti ya, soalnya ada sengaja.
Ganti tapi namanya ganti ini sama nama
Nggak masalah.
Oh, bikin yang jadi.
sebenarnya kalau mau ini
Kita
atau mau gua ganti rem
bikin
sekarang
bikin kemana?
OS saya bisa nggak sih?
Alamatnya apa?
Tanya si DCP itu.
Udah disiapin sama teman. Iya.
Oh ya udahlah.
Paham di mana? Wow, boleh ya. SSD lanjut ya Allah. Apa buat sesuatu?
Ada workshop ada alamatnya.
Tuh.
Iya, biru.
Kita nanya ke
Panah yang beli.
tadi saya catat
Okay, we got 22 students on my records. Yes. How many of you weren't here last week? Two. Just two of you?
last hour I was
Oh, the last hour.
I was not here last week because I signed up for a different elective.
Okay, so you just changed your elective. I see. Okay, so most people were here. I thought semester 7 you had a time conflict,
making late.
but you catch up like in the middle, right? The last hour. Okay. I'm gonna post the recording from the first hour or two. I keep forgetting to do that, but I downloaded it from the CCTV, so you can watch that. Okay, so most people are here today. At least Alfred Cesar,
He's in Germany.
he's in Germany. So he's doing it remotely?
Yes.
Okay. Another student contacted me too, Jonathan.
Margono?
Yeah.
Yeah, he's also in Germany.
Felicia.
Also in Germany. Is there a Catherine as well? They
So
contact
3 of them.
Yeah.
I'll have to come up with some assignments for them. Okay. All right. So today's session is on material handling. Let's begin this course, kick us off on material handling here, because remember I told you in the previous session about zero value added processes. Okay, zero value added process. What's the definition of zero value added?
Processes that doesn't handling, so there's no product is not changed or there's no value added to the product and things like that.
Okay, there is no value being added to the product.
No change was made.
Give me an example of value in product manufacturing.
Raw
Yeah.
to unfinished, unfinished to
Take
finished.
your phone, for example, right? So, the steps of manufacturing this phone from scratch, okay? Give me some value adding along the way,
CNC milling the chassis.
okay? Milling the chassis, the aluminum chassis, making the pockets, making the holes. So, the milling process is value adding, right? What are some value adding processes other than machining? Soldering, okay? So joining, creating electrical contacts, programming, okay? Distribution where?
I guess from the factory to the store.
Okay, so from the factory to the store because it's reaching the customer. Yes, it is value adding. Like if you think of delivery of aqua gallon, right? In that business, the water, you know, the water is pretty much value. The value of the water is so small, right? The plastic bottle, this plastic bottle costs more than the water. But it has to be there. How can you deliver the water without a container? And even further down the value chain, from the factory to you, is even more expensive than the bottle. The gasoline to take this from the filling place to you is more expensive. So really what you're purchasing is gasoline there, right? What you're purchasing is the transportation. So the business of selling aqua or aqua gallon for that dispenser is really a logistics business. You're not selling aqua gallon, you're selling delivery service. Because that's what you pay the most in that price. So yes, it does have some value adding from the factory to the customer. However, within the factory, right? Within the factory, the material handling is zero value. Because ideally, right? Ideally, when we're doing this, ideally this sits on this table from start to finish and people just come and work on it, right? I mean, that's of course impossible because there are machines coming to work on it. But that's ideal. Like transporting it from this table to the next table is not adding value to this thing. It's just something you have to do. Okay? So transportation is one of the few very fat percentage of time in the manufacturing process. Another one is quality check. Okay? Quality check, you are ensuring the value, but you're not adding the value. Okay? So that's why these processes are most often automated. And we're talking, this course is automation machine design. So when you design machineries to automate something, this is one of the very common ones. Usually one of the first one to automate when you want to modernize your factory. So today we'll talk about uniform versus variety part size and shape handling. Even though that's more toward the pick and place systems, we'll talk about conveyor systems and feeding systems. And you know, nowadays learning is very different. So today, as opposed to last year, I would like more interactions and more in-class activities. Last week we did some debate about human versus machine. I think that's fun. I also want to do some in-class activity for you to do your research. You know, use ChatGPT, YouTube, everything. Okay? But we'll mainly talk about conveyor systems and feeding systems.
I want to ask,
Yeah.
for the activities, last week, Thursday, right? We wanted us to go to meet up at a certain convention. Will that be like fine? Is that
Convention?
yeah? The exhibition.
Oh, the trade show.
Yeah.
Yes, that is. When was it again?
October.
October. Yeah, probably like the 4th week or the 5th week. We will not have a class. We'll just go there instead, and I'll give you some assignments. This class is pretty big, so we cannot go together. But you know, we'll gather in one place when we begin, and then we'll gather in one place when you're done going through the exhibition.
Will the day be on the Thursday, like this class?
I don't know. We'll see.
We'll see.
Yeah, we'll see. But yeah, I might have to cooperate with another lecturer to cancel the class for the day because it's probably a day trip.
But it's 90% gonna be, most likely gonna be,
Oh yeah,
most likely.
yeah, that's very likely. Okay. All right. So coming back to this, uniform versus custom parts handling. Which one is easier to automate in terms of handling? Uniform parts or variative?
Uniform.
Uniform, obviously. Because you can create jigs, you can create, you can predict what the conveyor width has to be, right? Now, if you have variation, like for example, logistics, JMA, right? Shipping your e-commerce products. The part can be this big, it can be huge, and so your conveyor needs to accommodate all of them. Now, with universal shapes, you can handle it with hard gripper fingers. You can grip on locating features. Like if it's predictable, then you can grip it on the surfaces that you want to. You can use jigs to locate it. Like if you want to machine on it, your conveyor has to have jigs to hold onto the part. You can do faster cycle time because it's located precisely, so you don't have to like search for it, right? So moving conveyor pick and place is possible, meaning like while it's moving, a gripper comes in and pick it up, and it doesn't have to stop, okay? If it has a jig. With shape variety, you have to have flexible fingers. You cannot grip on a single locating surface. Like think of a snack, like a snack pack. You can use suction cups to pick and place, but you're not going to grip on the same spot. You'll just try to be in the center. So there is no locating feature, that's what I meant. But rigid parts like this, you can clamp on the sides. Sometimes there are holes for you to actually put it on. Those are called locating features. Okay? With variety, variable parts, you cannot just grip it on the same spot. In addition, you might need some vision system to know where things are on the conveyor, right? So you have to know where things are if you want to pick and place on the conveyor or from the conveyor. Need some flexible recognition system, usually a camera, and the camera will just try to locate that. You might need a stop station, like it stops first instead of keep having like the continuous conveying. Okay? What's the disadvantage of this design? If the conveyor needs to stop?
Downtime, less. No production
Reduce production rate.
Yeah.
What else?
Stop.
You stop and go, stop and go.
The machines needs to be synced, I guess. The production needs to be synced.
Okay, the programming is more challenging,
Because
right?
it will cause a jam if that's not time correct.
And it might fall off. Like when you stop, things might be tipped out a bit. So jadi miring gitu kan? It's misaligned from the original one. So stop station, if you can do it continuously, that's best. All right. So let's talk about the types of conveyor, and I'll be playing some YouTube videos here.
Conveyors are designed to move material or products to improve efficiency and throughput. In general, conveyors are used to move a product from one location to another. Conveyors are used in a variety of industries, including material handling, metalworking, industrial, food processing, distribution, cosmetics, medical and pharmaceutical, plastics, packaging, automotive, and much, much more. Almost all processed or packaged products are moved on a conveyor at some stage in their life cycle. There are a variety of reasons to install conveyors, including product movement and flow, improved efficiencies, labor savings, speed and throughput, safety and ergonomics, reducing product handling, food or product safety, to protect point-of-purchase appearance, and product quality. In general, there are four main ways to use a conveyor: input and output to or from a machine, moving through a machine, bridging between machines in line, and mainline conveyance. Many conveying methods exist. However, major categories include mining and aggregate, screw, gravity, belt, precision belt, plastic chain, and pallet handling. When looking specifically at packaging and light industrial conveyance, each conveyor presents a variety of features and benefits. Gravity conveyors are a simple, low-cost method for product handling. They can be designed to operate with or without a motor, and are typically used in distribution centers and case conveyance applications. Belt and chain conveyors are the most common method and can be used for product control, inclines and declines, added flexibility, and increased efficiency. When deciding between a fabric belt or a chain, the application will dictate which one to select. Fabric belts feature a tighter belt pulley wrap for small product transfers, can often run at higher speeds, and provide more precise movement. In addition, they're often cleaner and produce less debris than modular belts. Chain conveyors are ideal for accumulation applications, curves, heavier loads, and mass flow applications. Chain styles vary and are generally categorized into modular belt and flexible chain styles. Precision belt conveyors provide precise product movement, often referred to as smart conveyance. And operating like a machine, precision belt conveyors use belt tracking versus a crown pulley. Another method of conveyance includes pallet handling. Conveyors can be constructed with several frame materials, including aluminum, stainless steel, painted steel, and more. Frame selection, belting options, and components are dependent on industry regulations, application environment, and product specifications. Beyond standard product movement, conveyors can be used to rotate, divert, sort, accumulate, reject, merge, and inspect products. Conveyors can be equipped with a variety of motor and controller options, stand options, and accessories. Conveyors are often integrated with robots for maximized automation. Dorner manufactures a variety of custom aluminum and stainless steel conveyor systems designed to maximize efficiency and productivity. For more information on conveyor applications, visit dornerconveyors.com.
Alright, so this is a good overview of what's out there in terms of conveyor belt systems. Now we say it's belt, it doesn't have to be like belt, right? You notice that these are not regular belts. There are rails, there are, what do you call that? Like, yeah, stops or plates to actually hold your pieces. So you see that depending on the item you're trying to transport, like here are what? They look like candies to me, right? So just a bunch of candies. When you go up an incline, it's going to slide unless you have these these plates. Okay? Now these are kind of a plastic chain conveyor. Notice that it can go around. Do you notice how it does that? How come you can twist this plate? Huh?
There's like a few chickens.
Anybody notice how it's constructed?
I think there's bearings on the side. There's like a chicken, so you're able to.
Okay, but the plastic pieces are joined with a pin, and it's actually pin in a slot. Okay, pin in a slot. So you can have a variation between the pitch. So it's not a fixed pitch. The pitch can stretch or shrink. So these plastic links, they can slide with respect to one another. So when you make a turn, right, the outside has to be stretched longer, and the inside radius has to shrink a bit. So it does have that flexibility. Okay, so you can go up, down. Okay, now this is like a continuous belt conveyor. If you don't want anything to catch, then just have a flat rubber belt there. It's cheap, it works. Now, locating these things needs a precision stop. So sometimes you'll have this continuous belt, but actually the rollers at the end is indexed, meaning like it has a timing. It's a timing belt, essentially, right? So the motor can stop at a certain angle of rotation that you need to stop. So again, you notice these plastic piece, they have links, right? The links can slide. Now when you stop this, you notice that the conveyor is still moving. So notice that there is a point where the conveyor is moving, but the item is stopped, and that's fine, right? So it's sliding underneath, and that's fine. You're not damaging anything as long as you actually plan for it. So the sliding effect is fine. Sometimes you just stop your product to work on it, and then you let go again, and it just goes. So that's not a problem. So you do sometimes want some sliding action. Okay, so let me just comment on some of these as we just go through that again. So yeah, you can make turns, incline, decline. Here's a spatial kind of conveying, right? Because it's not items, it's just bulk pieces or products or sand, salt, rocks. So in this case, you're just transferring bulk items. It's not a unit item. So this is called bulk conveyors. And then we have screws. This is also bulk conveying, meaning like just throw a bunch of it and then it just moves everything. Okay, so this is a screw conveyor. It's kind of similar to a screw dispenser, but I guess it's not dispensing, it's transporting. So it's moving things along. Okay. Now, usually if you notice, things always have rails. These conveyors always have rails to steer the products on the conveyor. So I'm just giving a general explanation of things. Okay, you notice this pin, the distances can vary. This is called pallet handling because you got two rubber belts, and then a pallet sit on top, and then your products sit on the pallet. So these pallets actually keep going around. You have like say 100 of them, and they just go around. The product will be taken off it, but the pallet, you have a positioning of your product in the middle. But your conveying is only like two belts at the edges. Okay, you got the plates, right? Gravity conveyors just slide. It just slides. It doesn't have motors on it. It's quite called gravity.
But
Yeah.
if it's gravity, what if like the object is heavy? Wouldn't it like roll faster?
You can control the angle, right? And by the way, heavier objects doesn't go faster than lighter objects, right? That's physics. Yeah. It just depends on the angle and the friction. Okay, hygienic conveying. Remember, if it's food or drugs, you have to make it hygienic.
How do you clean the holes if it's handling food? Like that has a lot of purposes, right?
Yeah. So if it's something that can crumple, you have to watch for that. Probably best using like a continuous belt instead. These things can be clean. I mean, just jet spray it, but yeah, things can get stuck inside. But there are plastics that are food grade and non-food grade. Teflon's usually food grade. So. Okay, any questions so far? Pallet handling. Now, we will look into the mechanisms of these belt adjustments because you do have to adjust them from time to time. Okay, the tension on the belt. Okay, so I put some links on the PowerPoint that kind of describe the different types here with some write-ups. You can read on them. Flat belt conveyors. And we'll look into this some more as you do your A-class exercise, but there's basically a motor with some gear set. There's some belt or chain. Of course, this class is a continuation from our previous class, which is machine design. You learn about these chains and belts, right? And then you got the frames. And at the ends, you got the rollers. Okay, so this is more modular. Modular belt, pleated belts, those plates, right? So you can carry things vertically. Curved belts, incline, decline, you just adjust. These things are designed so you can lift up the belt easily, just wash underneath, so you can wash everything down. Usually food processes, right? Okay, so that's a good article to read. Here's another good article. We won't read that right now, but you can go through it and just read the advantages and the disadvantages. Okay, I mentioned some of them already. Okay? So, let's go through some spatial purposes. Here's a gravel conveyor. Okay, so you see there is a paddle scooping it into the belt and then goes up. Now, most likely it's a steel belt. It has to sustain the abrasion because you're gonna basically rub on it. And you do actually have to maintain these things because it does get thinner because these rocks basically, think of it like sandpaper, right? You basically have a lot of abrasion going on here. Here is another spatial conveyor. It's sorting, so you got a combination of things here. Okay, I can even pause it. Okay, so you got sections of regular belt conveyors, and then you got these rollers which have small motors that actually throw it out and redirect it to the sorting lanes. Okay? Think of it like JNA, right? Shipping these boxes. You read the barcode, it knows which destination to go. And so logistics in itself is a whole entire science in itself, because you can simulate things like how to optimize your routes. So these will be lanes where it will be handled to the next destination. So here's an interesting design. It's called the telescoping conveyor. Okay, so you notice that the belt go around, there is a additional pulley that enables you to basically extend. How do you hide that? Okay, so this thing can retract. Can you think of a reason why you would want to use something like this? An application.
Maybe it's a job system.
area with other moving pieces that needs to be passed.
Can you speak louder?
If it's like a high traffic area where like you have to have like other machines or like humans move through, but it's a
Okay, so sometimes forklift might need to go through,
Maybe it can
and your space is just limited. You have to go. You have to have a conveyor belt, but at the same time you need something going across.
maybe a bit more an efficient way of with space. Maybe redirecting it into another conveyor. Maybe like to differentiate between. Maybe if you want to differentiate between like the small and big boxes, so instead of like putting another push to the side, so it can just drop down, so it's like more space efficient.
Okay. Okay, so different size boxes.
Yeah.
What do you guys think about that? Does different boxes will need this telescopic belt conveyor?
Doesn't need to, but it can be a solution.
Okay.
That's it.
What other applications can you think of? What about portable conveyor? Right, you can store this more compact. Sometimes you handle things that need the conveyor, sometimes you don't. Think of a small factory. You know, not all factories fixed, like it operates the same product every single time. So this can be a portable one. It'll be interesting to think of the application. Okay, so here is a situation where you basically have indexing jigs, right? So when I say indexing, meaning it stops at a certain index, and then you work on things. You know, these are the assembly stations. Maybe it does assembly, maybe it does some quality check. So the conveyor is spatial purpose built to this entire arrangement to stop at a certain assembly location. So sometimes a conveyor belt will be integrated into a bigger system, not just stand alone like that. So here's a way to adjust the belt. Okay? So this is how you join the belt. And this is the pulley with the bearing. You know what this is called? Pillow block, okay? There's a shaft. This is the pulley, the drum. You can think of it like a drum. It has a bearing. Now, this pillow block can be adjusted with this threaded rod. So as he tightens the nut, it actually pulls on it, and so it tightens the belt, right? So can you see that? So the location of this axis, as he rotates this clockwise, if it's a right-handed thread, it's going to pull on this thing, and so it becomes tightened. So you might need to do this every so often because the rubber can stretch. All right, some more examples here, okay? Just looking at more of these helps you to be familiar with just so many different types. So this one doesn't have a belt. It's just a bunch of rollers. I think I still have another video going on here. Hold up.
Third task.
Yeah. So a pretty flexible one. Now, not all of these are driven. Sometimes you can have idle rollers, and then you'll have driven rollers. Not all of them are driven with a motor. And sometimes one motor can drive multiple rollers. So you can put laser sensors there. So notice that they are joined with these belts. So they rotate together. They are linked to the next one. Okay, so you got the guardrails. You can adjust the guardrails to be a bit wider, is what it's saying. So it's like a Lego piece. You can just join different sections. That's the diverter. So you can divert this way or turn to the left. And this can be controlled, integrated with the computer programming. For example, you scan the barcode on the RFID, and depending what height it is, then you turn left or you go straight, right? So this just shows you the design, the inner intricate design of it. Okay, so let's look at this one. So this conveying system goes very slow, and sometimes, a long time ago, I did a project with Honda, and I had to be put on the line to assemble the cars. And I would be standing on a moving conveyor belt. So I'm moving with the car, assemble it, and then I walk out from the conveyor belt, walk back, and then do the next car. Okay? So So you can have huge conveyor belts like this, and the entire product basically moves along very slow. Okay? So you see that the guy actually moves along with the car, and then he steps out and walk back. So that's how you can just keep, instead of the worker moving, then the car is the one moving, because you have these jigs and all the tools come from the top. I think when I worked, we produced like 800 Honda Accord per day. It's like a 2 kilometers long assembly line. Very long. Okay, so that's moving assembly line.
Behind this highly secured door, an ASML camera. There's a giant $400 million machine. It's bigger than a double-decker bus. The city made with such closely protected technical specificities of
Very complex. The most advanced machine tool in history.
that no filming's ever been allowed, even by ASML's own team, until we flew across the world to see it. We're here at ASML headquarters in the Netherlands, where 100% of the world.
Close that. Okay, Conveyor.
Das
Omnidirectional.
Conveyor ist ein modulares Förder- und Positioniersystem, das auf dem Ansatz zellularer Fördertechnik basiert. Das System besteht aus mehreren kleinen sechseckigen Fördermodulen, in denen sich omnidirektionale Räder befinden, die jeweils von einem elektronischen
I
Motor
was going to
angetrieben
translate
werden.
it. Hold on.
Durch die spezielle Anordnung der Räder sowie das gezielte Ansteuern der einzelnen Antriebe können mehrere Objekte gleichzeitig und unabhängig voneinander auf beliebigen Bahnen bewegt werden. Komplexe Materialflussaufgaben werden mit dem Conveyor auf kleinstem Raum erledigt. Dank seiner hohen Flexibilität erfüllt das System alle
Okay, look at that. It
Anforderungen
can
der
move it anywhere.
Systeme unter gleichzeitiger Einbeziehung wirtschaftlicher Gesichtspunkte. Die Gesamtfunktionalität des Conveyor kann auf Knopfdruck angepasst werden. Ohne mechanische Modifikationen kann mithilfe eines Software-Updates ein einfacher Förderraum mit Ausschleuser zu einem Sorter oder Infeeder umfunktioniert werden. Der zellulare Grundgedanke
You have to be a German to come up with such an idea, you know?
Einfache mechanische Verbindungen zwischen den Modulen ermöglichen ein unkompliziertes Entfernen oder Hinzufügen. Dabei wird eine Änderung
How much
des
you think
Layouts
this
in der
is?
Steuerungssoftware detektiert und entsprechend angepasst. Größere Stillstandzeiten fallen.
One of those panels costs like 100,000.
I don't know how much, but I don't think anyone will be able to afford it. It's like it's hard to justify the investment.
Kann der Conveyor an den neuen Durchsatz effizient angepasst werden. Der einfache mechanische Aufbau sowie die Verwendung von Standardkomponenten und Schnittstellen ergeben eine hohe Robustheit. Sollte ein
But it's cool. It's really cool.
Deaktiviert und umfahren.
I'm not denying that.
I mean, those are just keyboard motors.
There's like 3 motors.
Yeah, but the program.
Yeah.
A lot of kinematics there. Who's taking kinematics? Are you guys taking kinematics right now? No? You did? Yeah.
I'm done with that course.
Painful subject.
Don't need to say that twice.
So yeah, interesting stuff here. I don't think anyone will buy it. Way too expensive.
I mean, it's probably cheaper to just put a human in there who arrange the boxes, right?
Not in German, unless if SU students work on it. Yeah, it's cheap.
They'll get paid half the price, yeah.
SU students are cheap. Cheap labor.
Free labor. Basically free labor.
Tapi banyak yang kerja di laptop kan di Jerman.
Yeah, they're getting paid 800 a month.
Makanya cuma 800 sebulan.
Minimum wage 2,000 something.
So here's a diverter. I think this makes more sense instead of everything is that, right? This one you have the regular conveyors and then you got that piece to synchronize with the assembly line. let's see. Here's also a palletizing and sorting application. This one, you see, how does it move? How does it shift it? Hmm? Make a guess.
Each link in the conveyor has motors.
That many motors?
Oh,
yeah,
it's the diagonal motors.
Oh, yeah, it can rotate.
It's like diagonal motors.
The roller is the conveyor at the bottom.
Whether it's an individual motor or conveyor, I think it's supposed to underneath that runs rollers. So there's like a conveyor underneath the conveyor. Yeah, so there's two conveyors.
That's how you connect them.
So it's like free moving. Right.
So the top
So okay,
is
so
the one that
I think how it works is there's two conveyors moving at the same speed, and when it wants to stop, it stops on that side, causing the rollers to move.
Nah, ini kan ada rollernya. Ini jadi
Yeah, because if it's static, that means the rollers are moving. So it's
so it just moves by inertia.
Yeah, so there's like small conveyors at the bottom at specific points.
With
Makes you curious, isn't it?
Tapi ini sebenarnya kebalik dong. Kan roller dia rotate ke sini, dorong.
Yeah. So it goes with it first, and then the roller will move, and then the other way to throw it.
So you can determine when it shifts.
And so there's like multiple small conveyors underneath.
Yeah, it pushes the rollers.
So would you like to get two for one conveyor? Would you like to have two conveyors for one conveyor? Here it is.
Yeah, you can do that.
Yeah, how do you mean work?
So you can
There's like two of them underneath. I thought you could.
How do you park them?
Or you specify like a specific conveyor as well.
I'll let you ponder on that.
Then it gets pushed up and then spins and then
Okay, I'm lost.
Oh, wait, no. Because one of them is moving faster than the other one.
nah itu ada satu ke sini, satu ke sana.
Yeah. So, okay, wait. There's just conveyors.
The one on the right is faster than one on the left.
Yeah.
Oh,
There's a
iya.
conveyor.
Oh, enggak itu satu arah ke sini, satu arah ke sana.
No, one is moving the camera and the camera.
Look at that.
That is flipping ski balls, not ski ball, I think.
Yeah, but they're also playing with the rollers right there.
Yeah, for sure.
So what do you think is the purpose of rotating this and arranging it in a certain way?
I mean, they're trying to pack it, right?
Uh-huh.
For pallets.
So to sit on the one single pallet, so you want a certain like Tetris, right? Like playing Tetris to fit it optimal. Have I made you curious enough to know how it works?
Yeah.
Okay. All right. So before you fall to sleep, let's do an in-class activity. Here's what I want you to do. I want you to research what conveyor type will you choose for each one of these materials. Okay? I don't know whether I have enough for you guys. 22 people. Okay? Why don't you just pick, read it across, and we'll get it, right? So you're gonna do, okay? Okay, keep reading. Airport luggage sorting. Okay? Read it. Mhm. Okay? Behind. Okay. Can you speak louder? Laundry bags. Okay.
Furniture panel.
Okay. Grain or rice. We're gonna do cement powder.
Coal.
Okay. Sugar crystals. Read it so you know which one is yours. Salt, and it's corrosive. Okay, I think we need to move today. Okay, why don't you start here? Because otherwise we don't finish. Scrap metal, okay? Not scarf, sorry, scrap.
What one you said?
Frozen meatballs.
Okay? Cling wrap sheet. Okay, it's the sheet, it's not already rolled. Okay? Okay, ice cube. Okay. So what you're about to do, you're gonna select a conveyor type matching for your choice of material. Okay. Remember, you can do ChatGPT, but you need to understand why that is so. Okay. So here, I told many of you in the beginning of the week 1 that ChatGPT is your friend. It's my friend to teach you. So you are learning together. What is important when you're using GMAI is not just to take it as it is, but understand the logic. And you can interact with it, okay? Now, once you select the type, I want you to actually look for it in the website and actually select an actual conveyor for your application. So I want you to browse the industrial catalogs and select one, okay? And study the catalogs, download the catalog, read it. Now, I want you to also design the motor. Just make some assumptions. I do not give you a specific rate, like for example, the rice, 1 ton per day. I'm just make an assumption that is realistic. Again, you can ask GPT to do that for that, and then design the motor calculation. Just use AI, fine. But I want you to understand how they calculate that, what factors come into play, and you're gonna present that to the rest of the class, and so we'll make this interactive, okay? So design your motor calculation, maybe some gearing, okay? Obviously, you will involve some gearing or chain. And then I want you to understand what can fail on that and how to prevent that with a proper maintenance. Okay? So what's the failure mode for your conveyor type, and then what kind of maintenance need to be done. All right, now I want you to summarize this in one Google Docs with pictures, YouTube links, upload the PDF of the catalog, etc. So I'll give you like, say, half an hour to do this, 20 minutes, okay? For your selected material, select the type, go to the websites and actually select an actual one. Okay, you can always upload the catalog to GPT and it'll study that for you. And you'll also study that together. Motor calculation and failure mode maintenance study, okay? So
So for the calculation, you can just like assume one.
yeah, just make an assumption.
Sir,
Yeah.
I'm not in the Google Classroom yet because I just transferred my laptop. So
Okay, you can email the assignment to me. Okay. And make sure you get to the classroom once your PCF revision is approved.
Right,